Hey everyone, this is Dr. Walker. I'd like to start this video off with a question. How is this possible? How are you able to change the frequency of the sweeps of the windshield wiper? How does that work? What kind of circuit is in there? So I'll give you a hint. This video is on RC circuits. Specifically in this video, we're going to deal with charging a capacitor. An RC circuit is a circuit that contains a resistor and a capacitor. Specifically, we're going to deal with them connected in series. The values of the resistance and capacitance determine the time that it takes for the capacitor to charge or discharge. So back to the windshield wipers, you can imagine that when you're turning that knob, you're either changing the value of R or C, and that's affecting the time to charge or discharge. So what we have here with this RC circuit is a sort of timing circuit. And that's how we are able to change the frequency of the windshield wiper sweeps. Here we have a battery, a capacitor, and a resistor, and a switch is open, so there is no current flowing. In the next picture, we have the switch at position A. So that means there's not going to be any current in here, but the current is going to flow from the positive terminal, capacitor, and resistor. So this would be a series RC circuit, and this would be the charging capacitor circuit. That's what we're going to be dealing with in this video. The other thing we will be dealing with in the next video is a discharging capacitor. In this case, the switch is at position B, so now we have removed the battery out of the picture. So all the charge that accumulated on the capacitor now is discharging through the resistor. That will be for the next video. Let's look at the concept of what happens when we're charging a capacitor in an RC circuit. So initially the switch is open and the capacitor is uncharged. There's no charge on it. What happens when the switch is closed, and I have a picture for it here, is that there's going to be a lot of current in the circuit, because when the switch is closed, there has not been any time for charge to accumulate on the capacitor. So it's as though the capacitor is not even there. It's not opposing the flow of charges by any means. So the initial current in the circuit is just going to be given by the EMF over R, and this is just using Ohm's law. Again, it's because the capacitor is almost non-existent at the instant the switch is closed, because no charge has accumulated on it. So the current only depends on the resistance. Now let's take a look what happens afterwards. After some time, charge starts to accumulate on the capacitor. We can imagine the current over here, and all the positive charges accumulating here, and all the negative charges accumulate down here. So after a while, and we'll talk about how long this takes, but after a while the capacitor is going to be fully charged. That's my bottom picture here. There comes a time when the potential difference on the capacitor is the same as the EMF of the battery, and so no more charge can accumulate. We have reached our maximum charge on the capacitor. This maximum charge is given by C times E. This is from the definition of capacitance, which is Q per delta V. And if the delta V on the capacitor is equal to the EMF voltage, then that's how we get Q equals C times E. When we have a maximum charge on the capacitor and maximum voltage on the capacitor, we have no more current in the circuit. It's as though we now have an open switch here. Current can no longer flow because the charge is full. And we have an equipotential surface on top here, an equipotential surface on the bottom. We're the same potential, and so there's just no more current flowing. Now let's take a look. I have 3 questions for us to look at that is going to emphasize the concepts that we have learned here. This first question says that the capacitor is initially uncharged. What's going to be the capacitor voltage at the instant the switch is closed? So pause the video and think about it. All right, so what we said is that when we close the switch, the capacitor has not had time to charge up yet. If there's no charge on the capacitor, that means that there is no voltage on the capacitor. So the answer is A. The instant the switch is closed, there's no voltage on the capacitor. Now, if you waited a tiny bit after the switch is closed, then the voltage would start to build up here and you would have some voltage between 0 and 6 volts. And then, and this is assuming that this battery is 6 volts, that's missing from here. Sorry about that. And when the capacitor is fully charged after a long time, then you would have 6 volts on the capacitor. Let's take a look at the second question. This is getting a little bit harder here. Just after the switch is closed, which is the same thing as saying the instant the switch is closed. So it's still when the capacitor has not had time to charge yet. What is the current in the battery? So take a minute. Okay, so the capacitor has not had time to charge yet. When that happens, it's as though the capacitor is not even there, right? So it's as though this is just a wire here, and we have a closed switch here. We have a battery, and we have two resistors connected in parallel. So to find the current in the circuit here, leaving the battery, this current, we're just going to use Ohm's law, which is the EMF over the R equivalent. And if we remember, when we have two resistors in parallel, their equivalent capacitance, since they're identical, their equivalent capacitance is half of any one of the resistors. Because they're in parallel, we're using the 1/over equation. So it's going to be R over 2. So the final answer for the current is going to be 2E over R. So it's definitely a lot easier when you see it worked out, but the takeaway message is that it's as though the capacitor isn't there when it hasn't had time to charge up yet. And now let's look at the third question. After a long time after the switch is closed, what's going to be the current leaving the battery this time? We're looking for the current. So take a minute. A long time after the switch is closed, that means that the capacitor has had time to charge up fully. And we said that when the capacitor is fully charged, there is no more current. So that means in this part here, there is no more current. So it's as though there's an open switch where the capacitor is when it's fully charged, because there's no more current in this part of the circuit. So if we're trying to find the current over here, we can use Ohm's law again, and it's just going to be E over R this time. So the takeaway message here is that when a capacitor is fully charged, then there is no more current in the circuit wherever the capacitor is at that part of the circuit.